Hello, my name is Gordon Milliken, and I want to share a little bit with you today about the use of artificial intelligence in 5G packet core networks. Well, what is artificial intelligence? It can be quite compute intensive, used for analyzing entire networks, but it also has applicability when it's used in local nodes to optimize individual application behavior. And so why the CMM? The CMM is MME and AMF, which are nodes that are central to signaling in both 4G and 5G networks. They see all the traffic in the network, and therefore have all the data that's very useful for artificial intelligence to create optimization. Lots and lots of potential use cases. Today, we're going to focus on one use case, and that is dynamic auto-scaling using artificial intelligence. So how does it work? Well, in this system, we have the call processing units, or service pods of the CMM, that are generating data, processing data, and we forward that to a new service pod that we've developed, the Machine Learning Information Service Pod, which processes the data with an artificial intelligence engine, forwards the data through custom metrics to our O&M function, which is then scraped by Prometheus, and those Prometheus custom counters are sent to Kubernetes horizontal pod autoscaler in order to scale the capacity of the system in and out. Well, what kind of work do we do to trigger this scaling in and out? We're looking at the normal daily variation in traffic, and as most people know, during the busy hour, traffic load gets quite heavy, and of course, overnight, traffic load can reduce by as much as 30 to 40%. Well, we can really take advantage here by reducing the size of the system to match the footprint with the actual load. If we look at the top chart here, we see that daily change, but if you'll notice looking closely, you may see that that change isn't exactly the same every day. There's daily trends. Different days of the week are heavier than others, and we can actually plot those trends of day-to-day behavior. And even if you look here, looking just at the noise, we can see that there's some predictable trends. So we can use mathematical algorithms to try to predict what these trends are going to be in the future. Looking here, we tried several different models. A univariate model, fairly simple linear calculation, was good for compute, but it wasn't accurate enough for our needs. We ended up going, and deep learning models were way too expensive for a local node. Might be good if you're implementing this at a network level with GPUs and those kind of processors. So we ended up using this univariate autoregression and linear combination to get really, really good correlation, R squared of 97%. And we use that data calculating and recalculating and refining the calculation over time to ultimately be able to predict what traffic load is going to be up to 3 hours in advance. Why 3 hours in advance is good? It means that you can gracefully use the automation tools of cloud native to be able to scale in or scale out the footprint so that we've optimized the compute resources that are required to run the application. If you're on a hyperscaler, you can save a ton of money this way. And you can also do this scale in and scale out to save on energy if you've already got dedicated resources. So now let's go and look a little bit. Well, I'm sorry. One more thing. As I said, we're taking the information from the service pod, sending it to our artificial intelligence engine, which forwards information to our O&M, and this is exactly what that is, custom metrics, and pay attention to this number, M225C000. That's the numbering of the custom metrics, which then gets scraped by Prometheus, and then forwarded to HPA for action. So now let's take a quick look at the actual demo. Here you see those custom metrics. Remember I told you to remember this number, M225C000. Those are the custom metrics that have been sent to HPA, and they have a value of 50 against a target value of 100. And that should mean, well, you don't have to take any action because the system is running as expected. When we look here at the ready for new scale, it says the recommended size matches the current size. We also have a min replica of 2 and a max of 4, which means we can't scale in or scale out too much. And we have a stabilization window that's fairly long here, 3 minutes, that dampens the response here so that we don't overreact or underreact to surges. So what we're going to see next in just a moment when the system advances is we're going to update the value when the machine learning pod detects that the scale has increased. We're going to see this current value change from 50 to a higher value, and that should be happening momentarily here. I guess one other thing we can look at while we're waiting is that the stateful pods that we're monitoring, 2 current and 2 desired, which means the system is under control. So here we go. We're now changing the time scale. And look, now we see that the current value has moved to 150. We still have 2 current and 2 desired. We have noted down here in the able to scale that something has changed. But remember, we have this 180-second stabilization timer that's slowing down the response so you don't see this instantaneously change. And what's going to happen momentarily here, again, we're going to move the time scale. And when we move the time scale, then you'll see the action taking place. And it just did. Here we go. Now we see 2 current, 3 desired. And we see that the HPA controller was able to update the target to 3. So HPA has noted this value change, it's executed through its stabilization timer, and it's updated. And now look here, when we count the number of service pods, we've gone from 1, 2 to 1, 2, 3. And in fact, just 47 seconds ago, we created that service pod. Now we're going to do the same thing, but in reverse. The artificial intelligence engine has just changed the value to 20, and so now 3 pods are way too many. And we'll go through that same stabilization period. Now the scale down indicator says I've got too many pods and I need to take action. And here we go. Right here. Now we see that we're terminating that extra pod. So this, by changing the custom metric based on artificial intelligence, we've both been able to use HPA to scale up and scale back in. And that's the end of the demo. Thank you very much for your time.